Hello friends, so today's question, four blocks are arranged on a smooth horizontal surface as shown in the figure. The masses of blocks are also given, and that's a figure to this figure. There are four blocks A, B, C, D, and A has, the top blocks have mass small m and the bottom one are having a mass of capital M. The coefficient of static friction between the top and the bottom block is given as mu s. What's the maximum value of the horizontal force applied to one of the bottom blocks as shown that makes all four blocks move the same acceleration? So force is being applied to the block B, and it is given that static friction between like A and B is mu s, and between C and D is also mu s. Okay. And we are going to find out what will be the maximum friction, maximum value of the horizontal force, that is value of the F. So first of all, let's define all the forces that will be acting on each of the block. Okay. So block A, block B, C, and D. So the external force F is being applied on the block B. Now this block B will try to move block A with the force, let us call that is Fr, which is nothing but with respect to the friction, and equal and opposite force Fr will be acting on the B block. Okay. And A and C are connected with a string, so there will be tension here, and this block will try to force, with the help of friction, will try to force D to move along towards the right side, and equal and opposite Fr will be acting on the block C. So these are the various forces that will be acting on each of the block with respect to friction at least, or we can say with respect to the forces. Okay. Now what happens? Let us find out the value of the static friction. Okay. Now we already said that block A will be moving with the help of only the static friction. So you can see in the block A, block A moves due to the static friction and its value, let us suppose, is given Fr, and we can find out the value of Fr. Suppose this is our block A, and we have mg in the downward direction, and let us suppose there is normal Na, so Na will be equal to mg, and there is a force Fr. Okay. So Fr will be nothing but mu into Na, mu s into Na, and Na will be equal to mg. So we can say that our Fr will be equal to mu s times mg. Now this force, we are going to find out what will be the maximum value of force. So if the force will be maximum, obviously this Fr will be up to its maximum capacity. Okay. You can say that for force F to to be maximum, FR will also be maximum. Which we can say will be given as FR max, and its value will be equal to mu S into mg. Now we already have the free body diagram of each of the block. So let us start first of all with our block B. Okay. You can see that for block B, okay, let us suppose, I forgot to mention that they move all blocks move with an acceleration which is equal to A. Okay, all blocks move with the acceleration A. So block B will be moving with the acceleration A towards right side. So we can say that F minus FR will be equal to, its mass is capital M, so we get this as MA. Let this be equation number 1. And similarly, we can now write for block A, for block A, it is also moving towards right with acceleration A, and you can say this FR minus tension T will be equal to MA. Let us call this equation number 2. Now for block C, so for block C, let me draw it here. This is block C, this is acceleration T, and we have FR and acceleration A, and its mass is small m. So we can write the equation as T minus FR is equal to MA. Let us call this as equation number 3. And for block D, so this is a block D, we have FR. It is also traveling with acceleration A towards right, and its mass is M, and there is no friction between the bottom of the blocks with respect to the ground. So we can say FR is equal to MA. Let us, this is equation number 4. So we use equation number 4 and 3. Okay. Using equation 4 and 3, we get T minus MA is equal to small ma, and from here we can write T is equal to, A can be taken as common, so this will be M plus capital Ma. This will not be tension, you can also find if required, and we already know the equation 2. Okay, so let me write here, from equation 2 we have FR minus T is equal to MA. We know the value of FR, we know the value of T, we put it here. FR is capital MA and this T is M plus capital M is equal to MA. I think I made a mistake somewhere. One second. Yeah, there was a mistake in putting the value of FR. FR we found out that is mu SMG. Okay, so we put FR as mu SMG and the tension is M plus capital M, and we get this as MA. We combine, write this as mu S mg will be equal to, you can take A as common, so this will be now 2m plus capital M. From here we can find out A will be equal to mu S mg divided by 2m plus capital M. This is the value of acceleration. And finally, we are going to find out the force. Okay, so we already know equation 1. So you can write from equation 1, which was F minus FR is equal to capital M. You put value of FR. So F minus FR is mu SMG, which is equal to M, and value of A is mu SMG divided by 2m capital M. So we can write this F is equal to, let us open the bracket, we get this as mu S M into capital M G divided by 2m plus capital M plus mu S mg. We can take mu S mg as common. This will be mu S mg, and we are left with M plus 1 divided by 2m plus capital M. Now taking it as LCM, this can be further solved as mu S mg get M plus 2m capital M divided by 2m plus M, and this will be 2m, means 2m capital M. So taking 2 as common. Okay, let me write it here, equal to mu S mg, we have 2m plus 2 capital M divided by 2m plus M. So it means the maximum force F is equal to, taking 2 as common, 2 mu S mg, we have M plus capital M divided by 2m plus capital M. This is nothing but the maximum force which can be applied so that the blocks moves together. Okay. You can say maximum force that can be applied for the blocks to move together. Thank you.